Here we're told we're asked to balance this redox reaction in acidic solution. That's really a key indicator that you're going to follow that specific procedure on the worksheet that I passed out in class. This is really the only case when you follow that procedure, at least until you take Chemistry 550 or 580. What we first do is start off by assigning oxidation numbers. Now I'm going to go to the products first because I think they're easier to assign, at least initially. Here note that the chromium is not neutral. It has a +3 overall charge, so its oxidation state is +3. Oxygen comes first on the carbon dioxide. Here, same thing, oxygen is going to come first, 2- overall charge, so that renders the chromium at a oxidation state of +6. If we look at the oxalate anion, we have a -2 oxidation state on each oxygen atom, and that requires a +3 oxidation state on each carbon. Now we have a situation where we can clearly see that the chromium atom goes from +6 to a +3 oxidation state, and you can see that here. Whereas the carbon atom goes from +3 to +4. So in this case we would say that the chromate, the molecule as a whole, is being reduced, and the oxalate, C2O4 2-, is being oxidized. So I would note that the C2O7 2-, I'm just going to do this for practice, is being reduced. And you can remember this by a Leo goes grr or oil rig. If you're gaining electrons, you are going down in oxidation state, so you're going from +6 to +3 here. And if you're Leoing, you're losing electrons, you're going up in oxidation state. So we would say that chromate, which is the species being reduced, and C2O4 2- is being oxidized. Now I know it's confusing, but we would also say that this is the oxidizing agent because it allows for something else to be oxidized, and whatever is oxidized is the reducing agent because it enables something else to be reduced. So you have to get that terminology down. I know it's kind of confusing, but it is what it is. So I'm going to start off by splitting up the overall reaction into half reactions, a reduction and a oxidation, and you just basically take the reactant that's being reduced or oxidized and move or show it going to the product that is on the other side of the equation. Let's take a look at the reduction first, the reduction half reaction. And this is a reaction that confuses people and leads to errors on tests, and that's why I picked it. Remember that your first step is to balance all the atoms that aren't hydrogen and oxygen. So the first step here is to actually put a 2 in front of the chromium 3+ to balance out the chromiums. Next we want to balance out the oxygens with the addition of water. Water is floating around in the aqueous solution, so that's perfectly legitimate. Next thing we want to do is add H pluses to balance out the hydrogens. So we would add 14 H pluses here because we have added 14 hydrogens there, and then we need to balance out the charge with the addition of electrons. The net charge currently over here is 12+. We need to include the 14 H pluses, that's 14 positive charges. The net charge here is 6+, so to balance that out, we can add 6 electrons. Now note, since this is a reduction, the electrons should be on the left side of the equation, and they are. So that's a good check that you can do as you're doing this problem on a quiz or a test, and you know you're going to see it on a quiz or a test. So I'll mark that that is the reduction. Oxidation. We have, and I'll do this in blue, C2O4 2- going to CO2. We balance all the atoms not called hydrogen or oxygen, so I'm going to put a 2 in front of the CO2. This one's actually kind of delightful because the oxygens are already balanced and there aren't any hydrogens, so I don't need to really do anything else. So this is a more simple half reaction. I still need to balance out the charge, and notice since this is an oxidation, the electron should be on the right hand side. Okay, so I have that there, and then I'm going to sum them up. I need to make sure that there aren't any electrons in the final equation, so I'm going to multiply this by 3. So that leaves me with 14H plus 6 electrons plus Cr2O72 minus plus 3C2O42 minus going to 6CO2 plus 6 electrons plus 2Cr3 plus 7H2O. Now that I have the overall equation, I always look to make sure that things cancel. The electrons have to cancel right off the bat. We know that. And now you have to make sure that there aren't H pluses on both sides and waters on both sides. If, for instance, there are 14 H pluses on the left, there could be 8 on the right. That would net out at 6 H pluses on the left. That isn't the case in this problem, but it is the case in other problems you will see, and probably one on your test. To make sure that I have the right answer, I always check the net charge. I find that that's a good way of doing it. Notice that the net charge here on the left is 14 H pluses from this character, 2 minus, 6 minus, so that gives us, I believe, 6 plus. Net charge on the right is 6 plus. That gives me strong evidence or strong reason to believe that this is probably done correctly. So you would just write it without the electrons, and that's the final answer.